Let's see. Thank you guys for joining. This is a live session, and this is going to be on the topic of science. My name is Amy Defoe, and sorry, we're switching out the offices today. So I'm in my husband's office. He works from home as well, so don't mind the background. It works as our office, our home gym, and a closet for him. So this is all the fun that we have working here from home. My name is Amy Defoe. I'm a science teacher here at Graduation Alliance. I probably sound familiar if you're in earth science or maybe in some of those videos that you've seen. That's me. I helped create the curriculum for the earth science and the biology courses. So here I am. Here's my real face. I'm going to go ahead and leave the screen up on the video. I think it's important for students, for you guys to see, yes, you do have a teacher. We are here. We are a live person. You're not just talking to a robot on the computer or whatnot, but we're actually, we're people. Okay. Sorry about that. A little pop-up came on here. So just a little outline here of the session. We're going to break it up into about 4 different sections. We'll have a 15-minute lesson. I'm going to go over the water cycle. And then we'll have an opportunity for you to ask any questions. Or if there's anything that you want to go over you're having trouble with, I can do that with you. And then I'm going to talk a little bit about vocabulary comprehension. I know science can definitely be pretty difficult, and some of those words that you see, you're just like, what? How am I supposed to remember that? How am I supposed to know what that means? And then again, we'll end with another question and answer series. How's that sound?
Good.
Awesome, thank you. If you would like to join in, you can ask questions as we have the audio going. You can ask questions there. Also, there is a chat. If you open up the chat, you can type in the question that you have as well. And I'll take a look at the chats as we go through. And then when we get to the question answer, I'll really focus on those questions. Great. Okay, so we're going to talk about, again, earth science. One of the bigger units in earth science, and this is in semester 1, is the water cycle. And so I wanted to do this first session on a big chunk of that water cycle. And then in other sessions, we can talk about other issues or topics that you might have questions on. So starting this out, we know that there are 4 spheres on Earth. And in this little picture, we can see there is 4 plus 1, and I'm going to talk about that other one that's in there here in just a moment. So we think about these 4 spheres that make up our planet. We have the hydrosphere, which is all of the water that is on Earth. And that's what we're going to go into. And then we have the biosphere, which is all the living organisms on Earth. So that's you, that's the insects out in the grass, that's the deer roaming in the forest. The atmosphere is the air in the sky that surrounds our Earth and acts as our kind of our protection layer. And then finally, the lithosphere is all the land on Earth. The last sphere that we see in there is, this is dealing with, anybody know what that is?
No.
All good. Those are looking at the different layers. So it's looking at the inside of our planet. So if you're in our science, you might know about plate tectonics, and it talks about the 4 different layers of the Earth. So that's what that little chunk in there is looking at, is the spheres, the layers of the Earth. And let's change this. Okay, so we're going to take a look at the water cycle. So just to start it off, you probably heard cycles before. We have lots of different cycles in our world, we have it in science. How would you guys explain what a cycle is, or how would you define it? Anybody have an idea? You can type it in, you can say
The only cycle I know about right now is the carbon cycle, because we had, crazy quiz on it and explain the arrows and different things,
What's going on? Okay.
Yeah.
If you had to say what a cycle is, like if somebody asked you, what is a cycle? Doesn't have to be carbon, doesn't have to be the water cycle, but how would you explain what a cycle is? Like what happens?
I would say it's basically changes.
Changes? Great. Okay, so we've got changes that happen. We can kind of say it's a series of events that occur. Does that sound right?
Right.
Okay,
You're
good.
right.
There's lots of ways that we can explain, but when we talk about a cycle, we're going to think about different steps or events that take place. And so we're going to look at that with the water cycle. This might look a little bit familiar to you guys. This is from the course, from the Earth Science course in semester 1. So when we talk about the water cycle, the scientists also call it the hydrological cycle. Hydro is another word that we use for water, and it's a type of recycling. So as you think about the water cycle, it's water on our planet being recycled, being reused, changed, transformed, over and over and over and over again. Some really, really important facts about water is that it naturally exists in 3 different states of matter on Earth. We've got our solid, our liquid, and our vapor or our gas. And here, as you can see, these kind of give you an example of the 3 different states. So we have our gas, and you'll notice that this is making up the molecules that make up the water, which is H2O, hydrogen and oxygen. And you can see that these molecules are really, really spread out. So where would you find a gas?
In the air?
In the air, you've got it, that's right. So you think about it, it's undefined. So those molecules are freely moving around. So we have water actually in the air right now. You might have heard of somebody, or maybe on like a forecast, they talk about humidity. That's the moisture that's in the air, the water. And then you have a liquid. So think about, you pour water from your faucet into a cup, and it takes on that shape of the container. So think about the water in a river or a lake. It takes on the space of that container. And then, of course, we have a solid, which is the molecules are very, very compacted together. And so it takes on maybe a shape that it is put into. Where would we find solid water on Earth?
Oh, ice cubes. I don't know.
Yeah, ice. Yeah, you got it. Yeah, ice. Ice cubes. You can think about ice cubes in your freezer. That is. You can talk about the ice up in the mountains or in glaciers. Exactly. Okay, so those are the 3 different states that we find water in. And in this water cycle, it transforms. It moves from different states. Another really, really important thing about the water cycle is that the amount of water that exists on Earth has always been here. It never changes. So it's kind of crazy to think about the water that you could be drinking like in your cup right now. This could have been, 5 years ago, it could have been up in a glacier, or millions and millions of years ago, it could have been a part of the ocean. So water is always transforming, but we're not losing it. Does that make sense? We can't make it. We can't make water, and we can't lose it. We have a definite amount here on Earth. Okay. The other thing about the water cycle is that it's a closed system, and that kind of goes into that where we can't lose the water, we can't change. It's closed, so there's no way for it to leave. There's things that we can do to the water that could damage it, like pollution, but there's no way for us to add more water, which is a really important topic for us and our planet. Okay, let's move on here. Let's move that out of the way. Thinking about our planet, how much of the Earth is covered with water? And you can see in there, we say about 70% is of our planet is water. So you look at a picture of Earth from space and you see all that blue, that's the ocean. Now what's really like a statistic or percentage that always just blows my mind away is we think about 70% of our Earth is covered in water. And then we look at, well, how much of that water is usable to us? And if you can see this picture here, it kind of shows us about 98, it's about 97.65, they say, % of all of the water on Earth is in the oceans. It's salt water.
Oh.
So you think about, here we have this tiny little sliver here of fresh water that's usable to us. And then in this next picture over, it shows us it takes this 2% of fresh water. So fresh water would be like what's in our rivers and our lakes and our reservoirs. And of course in the ice, it shows us that 87% of that 2% is ice. So think about like the glaciers and the polar ice caps. So really, what we have usable to us is this tiny, tiny amount. So that's why it's so important that we think about water conservation and pollution. Okay, so we talked about the 3 states. We talked about water distribution on Earth. Let's get to the water cycle. Okay, steps to the water cycle. There is, because it's a closed system, there is no start and there is no end point. So it's not like there's a, here you're playing a game, there's no, here's the start, here's the finish line. It's a continuous cycle. And sometimes it skips different steps and it can transform from one to another. So again, it's a series of events, but those series can change. Does that make sense? Kind of with me?
Yes.
I can't say the water cycle always starts with the sun, or it always starts with precipitation, because we have to have a step before that for that to occur. Okay, so I think the easiest way to start talking about the water cycle, though, is with evaporation, and we talk about the sun. Our sun is what gives us heat energy to make our water cycle work. It's kind of like the power behind this cycle. So the sun's rays, the heat energy that we get, it causes the liquid water, so think the oceans, the rivers, the lakes, to turn into a vapor, which we call a gas. And then this can move up into the atmosphere. So think about, I'm sure it's hot here where I'm at. I'm in Washington State, but I'm on the east side of the mountains where we get lots and lots of sunshine. So we think about, you water your grass or you wash your car and you see all that water on the ground, and then the sun is shining on it, and next thing you know, it's dried up. That's from the evaporation, from the sun's energy causing that liquid to turn into a vapor. And as that water vaporizes, those molecules move up into the atmosphere. So here in this picture, we can see this is going to be some type of a lake. And think of the sun would be right here, and its sun's rays are beating down and removing the water vapor, the molecules of water, up into our atmosphere. Okay. Some other ways that we can get evaporation is through transpiration, which is the evaporation of water from a plant's pores. This is really, really important. So when we think about a plant respiring, which is kind of like breathing, we breathe in and then we breathe out. Same thing with a plant. They have to breathe in, and then as they expire or transpire out, they're giving off water back into the atmosphere. And it comes throughout your pores. You guys do the same as you think about sweating from your body. When you sweat, you have water molecules coming out of your skin. Kind of fun to think about. Sublimation is a solid going straight to a vapor. And this occurs up in the ice. So in polar ice caps or in glaciers, where the water doesn't even, the water doesn't even get to a point where it becomes a liquid. It straight goes from a solid ice matter to a gas, okay? So as we're up here, as we evaporate up into the atmosphere, what happens is the water vapor, the water likes to join together, like it likes to group together, and so they're attracted, the water molecules are attracted to each other, and so they start grouping and grouping and grouping, and what we say is this is condensation, so they're condensing into bigger water molecules. You guys will see this when you say you take a shower, and on your mirror, you see all of that steam on the mirror, or you could say my water's not cold, so I can't even show you an example of that, but you have a glass of water or a cold liquid, and you can feel those water beads start to form on that glass. That's condensation. Okay, so the water vapor around it, those water droplets are grouping together and they're condensing. So when you think of the word condensation, think of water molecules grouping together, condensing. Okay, so now we have all these water molecules up in the atmosphere, and they're getting heavier and heavier. And this is where we get, say, like clouds. And clouds have got these water molecules that are grouping in together. Okay, and as those water molecules get heavier and heavier, they fall back down onto Earth as precipitation. You guys with me so far? Is it making sense? kind of just trying to go through these different steps and give you a little bit more background to it. Okay, so precipitation can take the form of hail, snow, rain. Those are all different forms of precipitation. So this is, again, water coming back, falling back down onto Earth. And as that water falls back onto Earth, it can form in what we call runoff. And this is when the rainfall and the snow melt, they're pulled downhill by gravity. And eventually the idea is that they get pulled downhill and they empty out into the ocean. Another part of precipitation, what happens with runoff is that it can infiltrate, or infiltration, where the, think about not all the water gets pulled into, say, a river. It doesn't move into the ocean, but rather it seeps into the ground. So think about when maybe you have a garden or you have a plant and you water it, and you can see infiltration happening when you pour the water on the plant and the water seeps down into the ground. So that's the infiltration. So those are the main steps of the water cycle, and kind of in details about what the different steps are. Does anybody have any questions about that so far? Okay. So again, here, another picture, and I wrote on here the sun. Any ideas where the sun might be in this picture of the water cycle, or what part the sun would take place at? Where is it missing? Where should it be drawn into the picture? That's funny because it's like all these pictures I'm finding on the water cycle. I'm like, where's our sun at? Where do we get that heat energy?
To the right.
To the
up,
right.
Up. I mean, well, obviously up.
Up here, yeah, definitely up here. Yeah, it kind of all depends on where we're starting at in the water cycle, where you decide to think about it. So, like we talked about in the beginning, this evaporation piece is a big one for the sun. So
okay.
The sun's rays are beating down onto that water, causing the water molecules to evaporate up.
Okay.
And so then again, so we have evaporation, water molecules coming up. We have transpiration. Again, that's the evaporation from the plant's pores as they expire out. Up into the clouds where those water molecules are condensing. And then we get precipitation, could be here. It shows you precipitation in the form of rainfall and precipitation in the form of snow. And then kind of different collections that we have of where we would find that water storage. We've got, the ice. We've got it in the river. We've got water here seeping down into the ground. And then, of course, the end point as it runs down, we call that, again, the runoff, collects into the ocean. So just a couple little practice ones I put on here just to make sure we get the idea of, again, there's not this stop and end, but it's rather a different series of steps and processes that the water can go through. So if we think about rainfall, what part of the water cycle would rainfall be considered? So we talked about evaporation, condensation, precipitation. Those are all forms of, or those are all steps in the water cycle.
You said the rainfall.
Yeah, what would rainfall be? What step or process in the water cycle would rainfall be an example of?
Precipitation. Precipitation,
exactly, yeah. Yeah, so you could say rainfall is the form of precipitation in the water cycle. You can see that here again. As that water vapor is condensing up in the atmosphere, it falls back down to Earth in the form of precipitation. Okay. What about water droplets on a cold beverage? What would that be an example of? What process, say in the water cycle? Water droplets on a cold beverage.
Condensation.
Condensation. Good job. You got it. Yeah. Evaporation from a plant's pores. So when those plants are exhaling or spiring out, they're giving off water. Do you guys remember what that one's called? It's a form of evaporation.
Right.
But it has to do with plants do this.
Plants respire, but
it
that's
starts
not
with, it's one of the words. It starts with a T.
Oh.
No.
Transportation. Oh no. I don't know where I got that word from.
Very
Transportation.
close. Transpiration.
Transpiration. Oh.
Condensation. Okay. The sun's rays, so that heat energy from the sun shining on the ocean. What would that be? What process of the water cycle would that be an example of? There we have the sun. Yay, we have the sun in this picture. The sun's rays are beating down. They're shining on the ocean, causing those water molecules to...
Sun's rays shining on the ocean.
Evaporation. Oops. Got it. Thank you. Awesome. It's great to hear some more voices in there. Thank you guys for sharing. Water seeping into the ground after a watering. This is a type of runoff. So as that precipitation, that water can pool together and move on down to the ocean, or it can seep into the ground. And we call this... Oh, damn. It's a tricky one. So looking familiar?
Infiltration and...
Yeah. Infiltration.
I probably said it wrong. Infiltration of...
Okay, last one I have is snowpacks melting and flowing in a river. So again, we have up here, think of this as probably, well, if you got mountains around you, I have mountains just outside the window here. The snow from the winter snowpacks are now slowly, or probably pretty rapidly with the heat that we've got here today, it's making that snow and ice that's been compacted up there all winter. It's beginning to melt and melt and melt, and it's flowing into a river, eventually heading to the ocean. What process in the water cycle is this?
Runoff? I don't know.
Got it. Thank you. Runoff. Okay. Good job. Okay. So any questions there about the water cycle? Is there anything that was still not making sense or you're unsure about?
For me, I just need to practice it. So.
I hear you.
I mean, keep, how you got the pictures up there and go through it all the couple of times, because
I think what gets really confusing about it is that we can't say like, okay, we always start here.
Right.
It's because it's like it's a cycle, and the water can, it's being recycled over and over and over, and it's changing. But we can't say like, okay, here's the instructions for it, and we go step 1 is this, and step 2.
Right.
The hard part about it is that it's a process. And again, like we can start it, up here in condensation with all those water molecules condensing and going to precipitation. So yeah, I think it's hard to think about it. Well, I just need to know where it stops and it ends, because it doesn't. It's a process about it. Okay. I just wanted to put in a couple, a little thing about how the water cycle affects us. Like, why are we learning so much about this? And as we think about on the land, we get land formations that are caused by this, by the water cycle. So we think about all that runoff that occurs. We get land formations in the form from erosion, as you think about like the Grand Canyon. Okay, that was formed by a giant, and they say like river cutting through the land. Think about glaciers, the same thing as we used to have glaciers farther down on Earth. We would, as the glaciers would move, it would cut through that land and carve it out. Also with sedimentation. So like here, this is a picture of the Nile River basin. So as that runoff, all that water is moving towards the ocean, it's collecting sediment, little pieces of dirt and sand along the way. And then it drops it at the mouth of the river. And this can make it makes very rich, fertile ground. So they can grow vegetation, gardens. And so it's important for that. We also think about living organisms, plants, and our cells. We need to have water to survive. We think about our bodies. Our bodies are made up of so much water. We can't go without it. We would all, if we didn't have water, there would be no organisms on Earth, pretty much. And then we also think about the weather. The water cycle is what drives our weather that we see. When we have precipitation, we have storms, it's caused by that water. Any other effects anybody can think of or want to share? Great. Okay, so that was a little mini lesson, a little more in-depth description about the water cycle. I wanted to open up questions. Is there any parts of lessons that you guys are here to ask, want some help on?
I actually have a question.
Yes.
Would dry ice be considered, I know it's a solid, but I heard some people also say it's a gas. How is dry ice actually formed?
Okay. Oh, good. The mechanics about dry ice. It has to do with what it's made up of. It's not just hydrogen, and so it's not pure water. It's not just H2O. But as you think about dry ice, that's actually what we call sublimation. That process where it's going straight from a solid. So when you have that dry ice, it goes from a solid to a vapor. So there is no melting, or what we would think about as melting. There's no liquid state of it. It's just going from solid straight to a gas in that form of that vapor. So you've probably seen dry ice. They use it like for Halloween and stuff to give that spooky smoke effect. So that's, again, that dry ice in a solid form is ice. Then it is going through sublimation when it is just kind of when you see that steam, that vapor rising out. I'm trying to see. The little chat button here is, might lose you guys here. Nope. Okay. Not seeing any other chats. Did anybody write in a chat there and I'm not getting it?
Oh, I didn't.
I had to use the bathroom. I think I missed something.
I'm sorry, I missed that.
I said I had to use the bathroom. I think I missed something. You said something about a chapter?
Oh, there's a chat function here that we can use that you can type in if you have a question.
Oh, okay.
If there was anybody that wrote in and I'm just not seeing it. Oh, no questions. Okay, great. Thank you. It is working.
Oh, I see.
Okay. So again, this is a great place if you, if you have a question now, that's awesome. But also think about in future sessions, your teachers are going to always provide you with an opportunity, a chance to ask some questions here. So if you've got stuck on an assignment or you don't know how to upload or download a document, or you don't know what the question's asking, or you're not understanding the material in the lesson, this is also a great place where you can get that immediate feedback from your teachers as well here. Okay. So keep that in mind. I will always take questions. I can move on to the next little section on vocabulary that I have. And if something pops up in your mind as you're thinking about that assignment that maybe you are about to start or started this morning, definitely bring that question up. Okay. Okay, high mass and low mass stars. Yes.
Yeah, it's very confusing. I'm like looking at 4 books at one time.
Are you serious? Oh no. Let me move this over here. There we go. Sounds like somebody outside. I hear some nice birds.
Me too.
I think that's me. I sit right by my window.
Oh no, that is awesome. That's cool.
Me too.
Okay, let me pull up. Sorry, I'm afraid that if I try and move this little toolbar, I'm gonna lose y'all. So I'm just gonna stick with it and go through this way. So hang with me.
Astronomy. Oh, they
This is the kind of looking that. So this is what I see when I log into the program. And let's go into. Let's take a look at.
oh yeah.
Does
Nuclear fusion, yeah.
Does that make sense?
Yes, definitely.
It does make sense.
The nuclear fusion I kind of got is just the the high mass, the difference in them.
The difference between the two. Okay.
The two, yes. I didn't know that the sun was a star, so there you go.
I know. And isn't it kind of sad to find out that our star isn't a giant star?
Right. Yeah, just I don't know what I thought it was.
Okay.
Stars and supernovas, yeah.
That was the clip. Let's go. Sorry, it must be here in this one where it explains those two. Okay. We'll pause because you don't want to hear myself listen to that. Okay.
No.
So 2 different types of stars. We have the low mass and the high mass. And the main differences between them is that, well, let's start with what is similar about them is that they both spend most of their lifetime. So yes, the stars also have lifetimes just like organisms do, where they go through different stages. And the main sequence stage is for each of them is where they have the most amount of time that they spend. So that's something that they kind of share in common with each other. Okay, so a major difference is that high mass stars are going to burn through their hydrogen a lot quicker than a low mass star. So when they burn through their hydrogen, they're going to the fusion occurs faster and faster, and then as they're burning through that energy, they're going to die quicker. So okay, that part makes sense. So the more that they're using up, the more that they're burning, their lifespan is shorter. So mass stars, they burn through the hydrogen much quicker and they die faster. So their life cycle isn't as long as a low mass star is going to be. Larger stars are going to burn far longer by converting their hydrogen to helium and eventually heavier elements. So they're able to keep that like a steady pace of burning through the gases that give them the energy.
Right. So that's the same as the sun, since it's not, I mean, I know it's not, they're all going to die. It just don't seem like it, because it's like what, trillion, billion of years or whatever that, I don't even know. So each star is helium and hydrogen which creates them.
It creates that energy.
Sorry, yes, okay. So that's similar in something else I could say that's the same. That they both, the low mass and the high mass stars, sorry.
Yep, you've got it. Yep, so they're both made of that hydrogen and that helium.
Okay. Okay.
The big difference is that the high mass stars, they're going to burn through the hydrogen quicker, and
Right.
their lifespan is shorter because they're burning through that more.
Okay. Okay. Thank you.
Oh, thanks for your question.
Yeah. Whew. Like I said, I went to the library and got 4 books, and it was like, oh my gosh, really? It's like,
Well, hey, when you have, a question like that, definitely you can send a quick chat to one of your teachers.
okay.
And email them and be like, hey, can you just restate this? Sometimes just having somebody say it,
Right.
friendly, makes all the difference in how it goes into your brain and makes sense for you. So,
Right. Because I'm more verbal anyways, or visual, I'm sorry, then yeah.
And sometimes you can also, if chats or emails aren't your preferred method of communication, you can say that, hey, I'm much more of a, I need to talk it out. Can you find a time to chat with
Exactly.
me?
Exactly.
Well,
That sounds good. That sounds good. Yeah. I'm gonna do that. Yeah.
good.
Reading it is sometimes not. I don't know what that's about, but.
And a lot of students in science, it can be very, very tough, and some of the courses I think are much, much harder than other courses. And
Yeah.
for me, and I love science, but I also give students, I can recommend outside resources as well that I have found that work good for me, because sometimes I have to go back and review this material. And
Really?
not all out there.
Right. Well.
we're all humans. We're always going to continue to learn. That's part of life.
True.
So we have to
That's true.
ourselves, and so I can give you and your other teachers in your other courses as well. They're going to know where you can find like a good resource too. So I hope you're not.
Okay.
Don't go out and spend tons and tons of time like looking for books and stuff like that.
Right, because that was crazy. You're right.
Use the resources that you have available to you.
Okay. Okay. Thank you again.
Welcome. Thanks for joining and getting that answer. Okay. Well, again, if you have something you want to add in there, go ahead. I'm going to continue on here and talk a little bit about some vocabulary strategies that have I find that are helpful when it comes to any type of vocabulary, but also science in particular. So we can think about all these words that we see, photosynthesis. Here's one. Maybe you've never even heard that word before, and you come across it and you're like, how do I sound that out? And there's lots of those words here in science. So, what I like to think about is like with this particular word, photosynthesis, as I look at the word, I always try and look to see if there's some type of a picture that goes along with the word. And this is just a quick little introduction. I'll go into strategies here in a moment. But when I think about this word, how can I break that word down? Whenever you have like a long word, can you break the word down into smaller words that maybe could give you a little bit more of an idea of what that means? So like in photosynthesis, I have 2 words here. I have photo and then I have synthesis. So when I think of synthesis, to me, I think of like to change or synthesize, so to speak. And then the other word as I see is photo. And when you think of photo, you think of light. So I know it has to do with something about changing light or converging light. So photosynthesis is actually how plants get energy by taking energy from the sun with carbon dioxide and water and producing sugar and oxygen. So, okay. So a couple different strategies that I find that really work really, really well with vocabulary is, my first one is just always background knowledge. Actually, like think about the word. Think about what does it mean to you? Give your brain a moment to kind of what we call activate your background knowledge. So if you think about it, your brain, this is kind of silly to think about it, but it's kind of like a filing cabinet. And we take in so much information every day, and then our brain, it just files it away. And sometimes it needs a little bit of help, and it needs a little bit of time to kind of go through and pull that information out. So I always like to say, give yourself a moment to think about it. Think about, do I remember ever hearing this? let your mind kind of make those connections first. Because then if you can make that connection, it's so much easier at remembering a word. It sticks in your mind so much more. Okay. So another strategy, those roots, prefixes, and suffix. So again, kind of like what I showed you there with photosynthesis. This is my favorite in science because it's a lot of times how I can make meaning of these words. So use parts of the words to figure out what it means. So for example, we think about biology. Anybody know what bio means?
Ooh. Hold on. I know what that means. Bio.
The study of something, right?
Okay, well, let's go ology. What does ology mean?
Ology?
Yeah, you had it. You just said it.
The study of, I'm sorry.
Ology is the study of. So it's whatever was studied. And bio,
Life?
Life, yes.
Oh my gosh, I just remembered that from medical school. Oh my gosh.
Knowledge, you made that connection.
Right, took me a minute.
Sometimes that's all it takes, though. That's great. So bio means life, and
Right.
ology is the study of. So when we think of the word biology or the course biology, it's the study of life. Okay. Another one like what we talked about here is hydro. When we talked about the water cycle, hydro means
Water.
And sphere. You guys know what sphere means? Shoot out ideas.
Circle.
Mm-hmm. Done here. Yeah, circle. So if you put those two together, it's the circle of water. So it's the cycling of water, like we talked about in the water cycle.
Oh, okay.
Another one here, read the sentence that it is in. So here was an example. The water cycle, which scientists also call the hydrological cycle, hydro being another word for water, is also a type of recycling. So when I see, they're talking about cycles and water and hydrological, I'm like, okay. But then I come to this word and I'm like, recycling. I know what recycling means, right?
Mm-hmm.
To change, to reuse. So as we think about the water cycle, it's the changing or reusing of water. So sometimes you can read a sentence and you'll find some words in there that help you create that meaning with it. So to me, when I think of water cycle, recycling comes to mind. Okay. Another strategy is look for an image. So here we have evaporation. And here is a picture of evaporation occurring. So what do you see in that picture?
Looks like steam.
Steam, yeah. Okay, so you can see there's some type of steam, and you guys know what steam is. What form of or state of water would steam be?
Like evaporation, right?
It is. We're talking about evaporation. So what state of water are we talking about with evaporation?
Gas?
We talk about, it's a gas. So we see the steam. So we're looking at that gas. So evaporation is the process of turning water liquid. So water from its liquid form. So you can see there's a little bit of liquid in that. Sorry, I really wanted to focus on this part. Into a vapor. We said steam, and it rises up into the atmosphere. So again, those pictures can definitely help create more meaning to. So when you're just reading through here and you're reading, okay, evaporation is the process of turning water from its liquid form into a vapor, which then rises into an atmosphere. You're like, oh, okay. But when you see
is that what makes it so damp outside after it rains and before it rains?
Yeah, exactly. So you can actually see it and visualize it, and you can think like, oh yeah, when I like make noodles, I boil noodles, I see this happening. You can make that connection, which is going to help it stick in your mind. Okay. Couple more here. I always think it's a good idea to keep some type of vocabulary notes or just any type of notes as you're going through a lesson or a unit. The way that the courses are set up is that you get an understanding of what, what is this unit going to be about? What is this lesson going to be about? And that's going to tell you what the expectation is, and that's going to tell you what the important pieces, concepts, words, information, all the good stuff. Or you're probably thinking, what do I need to know? What's going to be on the quiz, or what's going to be on the test? And this is going to tell you. So the unit introduction, as you open that up, you get your intro, and it gives you a little blurb about, why it's so important. So we're talking about water, and this tells you what the importance of water is to us, to kind of get you thinking like, yes, I need to know about water. And then of course you've got your lesson objectives in here, and it's going to tell you in this unit so you're going to be able to describe the physical and chemical properties of water, discuss some of the controversies, hot topics that surround water, and explain the importance of preventing water pollution, protecting water quality, and conserving water. So this is telling you right here, these are things that I should maybe take some notes on, or this is what I would take notes on, because this is what I'm going to be assessed on. Like at the end of the unit, you're going to be asked questions about that. And then in a lot of the courses, you're going to have some unit vocabulary, where it's going to give you the background, the vocabulary, the important words that you're gonna need. So looking at that, introduction I think is important. You can read through here and you'll find words that stick out, like, water cycle, liquid, solid, and gas. So it's going to give you an idea of kind of like, these are going to be the important words that you are going to want to know. And then again, when you get to the objectives, if there's things in there like chemical properties, you're going to want to know what those are. So it's great to keep a little jot down of some notes in there. Okay. So I always say, kind of in your notes, this is when I'm teaching vocabulary instruction, this is kind of what I always have students try to include, is you write the word and then you define it. So you can use like a definition that you get from a dictionary, or the definition that maybe is in the glossary if your course has one. Define it in a way that makes sense to you. And I'm going to show you an example, because sometimes the definition that you read from a dictionary doesn't help a whole lot, right? You're like,
no, yeah.
Like, okay, you still got too many big words there for me. Define it in a way that you're like, okay, I got it. I always say create a keyword for it. And then use images or draw a picture to help remind you, because sometimes, as we've heard, some people learn by talking, some people learn by more reading, watching. You're a visual learner, so these are kind of hitting on different modalities or different ways that you learn. Try to use the word in an assignment. So maybe that next assignment that you have in that activity, if it's a new word, make sure that you have to write a sentence that explains the importance of the water cycle, and try and put that word into that assignment so that you keep on using it instead of just like pushing it away and be like, okay, I read it. And then keep coming back to your notes to keep it fresh and to add on to that learning. So as you think about, usually in your courses, you're learning and you're building upon what you already know. So it's kind of like a continuation. Okay, so my example right here is cohesion, and this goes along with water. This is one of the properties of water. And so cohesion, does that sound like a familiar word, or is this a new word for you?
Pretty new for me.
Great, yeah. Well, here's
I've heard it before,
Okay, so here we go. A good example. First thing I would do is write the word out and define it. So cohesion, as you look up in the dictionary, it's the property of water in which molecules of water have a tendency to stick together. So water molecules, they stick together. We talked about it when I was going through the water cycle, and I was talking about how the water vapor evaporates up into the atmosphere. And then think about in those clouds, those water molecules they're condensing, they're sticking together. And so water is attracted to other water molecules, and that's this cohesion. Define it in a way that helps you. So how does it make sense to you? So when I think about cohesion, I think of water sticking together, water grouping together, water making droplets. Okay, so define it in a way that takes away that more formal definition and in a way that you can remember it in your mind. Create a keyword for it. So cohesion, as we talked about, water molecules. my key word is stick. So think of water molecules sticking together, gluing together, combining. It could be stick for you, it could be combine, group. So try to come up with like a buzzword for that definition. And then use images or draw a picture to help you understand. So here, as we can see, this is a picture of some leaves. We can see the water molecules, and what they're doing is they're beating together. Another great example of this is if you maybe see like on your windshield, if you're in a car and you'll notice like maybe it starts raining. Do you ever see, or maybe you're going through a car wash, that's a good example. The molecules, they kind of like, it's like you can see them actually be attracted to each other, and they like run into each other.
Right.
Together. So that's that cohesion. Water molecules have a tendency to stick together. So think of an image or draw a picture that's going to help you understand. And then try and use that word. Water cycle, you could talk about, condensation. As the water molecules evaporate, they condense, and because water is cohesive, has cohesion, they stick together. Okay, so these are some things that I find are helpful for me when I'm thinking about new words or learning new material, how I go about to kind of help it stick and make sense to me. Okay. Well, that was my little presentation there on vocabulary and the water cycle. Does anybody have any other questions? I'll open it up to if something popped up along the way or before we end. Anything, yeah?
I don't know. I'm not even sure if I even started on my science for the week or however, but I don't have any questions at the time being.
Well, that's good. And again, you always know, you guys, your teachers are going to definitely be responsive to, chat messages or emails. I know some people have different preference in what it is that they prefer to use.
Right.
But I know myself, I check everything throughout the day, check all the different means of communication to make sure that I'm there to help you, support you. I know how frustrating it can be that maybe you're working on an assignment and you get stuck and you're like, oh, I need that question immediately. And so always, ask. Your teachers will get to you.
I hit my coach up right away because you can text your coach from anywhere. Just be like, and they'll hit you back up and try to help. Huh?
I said my coach is great.
Good.
Yeah, mine. Yeah, they are. Man,
they are wonderful. It's
just
nice
like
to have this great, it's a great community that you guys have here.
right.
You've got, your coaches and your teachers, and you guys all working in here together. And it's I hear from coaches. They email me. I email them.
Right.
We're
Yeah.
all connected in here together to help you guys succeed. So yeah.
So the dude that's like early in the morning, when you get up early in the morning and you might walk through the grass and you have like the little water droplets stick to your socks. So that's the exact same thing as the cohesion.
Cohesion. So yeah, those water molecules sticking together. Yep. And that's the process of the water cycle where we think of condensation occurring because those water molecules are cohesive, wanting to stick together. They group together and create that dew that you see like on the lawn.
Regardless if it rains or not, correct?
Yeah, you're making those connections, applying it to what we see in our daily lives, which is, I think, really important in science because it definitely makes it make a whole lot more sense when you can think and be like, oh, that's there it is, it's happening right there.
So what's the difference in the fog? Like fog could be in the morning or fog could be at night.
Mm-hmm. So
So
water molecules, you think about it, it's like a cloud. Those water molecules are beating into
a lot, right? Because sometimes it can be seriously foggy out here.
thickness. Yeah. And if you guys have also suggestions, you can suggest to your coaches, and you can also suggest to your teachers, or you can suggest to me. Since I'm doing science, I'll be doing another session next Thursday, same time. So if there is a topic that you want to go over, or a unit that you want to go over, like plate tectonics, or if you're in biology and you want to do some biology or something, definitely throw me your thoughts so I can kind of plan what I think, I want this to be useful for you guys. So if you've got
Okay.
ideas or a unit you would hope I would cover, please let me know.
Okay. So since even though you're not my teacher, I can like send a question in. I mean, like global warming or something like that.
Mhm.
And
Like I'm
no,
not your science teacher. You have like Mrs. Harper.
yes.
Yeah, you can. Her and I talk. We also chat and communicate as well. So if you have questions, I would definitely I would ask her, but she can relay the message to me, or also your coach. Like if there's a topic that you want to take a look at. I know like you guys got the little form that went out in the announcement, and
Right.
some people filled it out, and so I had an idea kind of what was going to be covered, or what you were coming for the session. That's also helpful as well. So keep filling out those forms. Like I saw somebody had asked earlier about the star question, so I'm glad that that came up here.
Another question that I have is sometimes like they'll give you like two answers that can possibly be correct. Like hypothetically, they might say like, "What is a star?" And they might say like, "A star is a ball of gas." And then the other one might have another word used for it that's the exact same meaning. Like, how would we know exactly what is the actual correct answer to choose?
A couple things I would say about that is I would go, if you can go back into the lesson or go back into your notes and kind of look at the words that were used. That can help define it better for you. But if it's a question of, maybe I could see like if the question is worded wrong, that could be something that if it's mixing you up, making you think like I don't know which one it could be, then that maybe is a question that we need to think about making a change. Am I getting this out right? If you're thinking that the multiple choice questions are just too similar, and you're feeling like you're getting tricked, that would let me know as a teacher, like maybe I need to go back and like reword these questions better.
Right.
Because the idea is not to trick you up. Of course, with multiple choice questions, you're going to have, there's usually two that you're like, oh yeah, it could be this one or this one, right?
Mm-hmm.
Based
Right. Yeah.
based on what you learned from the course, you would know which one is the correct one. But if it's in the case where maybe two words are too similar and tricking you, then that could be something that we would look into and possibly changing. So in that sense, I would definitely reach out to a teacher. You could just copy the question and be like, hey, this question, I'm getting confused. It could be this one, it could be that one. Any suggestions? That would be what I would go back into the lesson if you can and see if you can find the wording, and then I would talk to your teacher about it.
Okay. And another question is, with my first semester of science, we dealt with, DNA, that type of thing. And then with this new science class, I haven't started that yet because of my English classes. But it's like the first week is still asking about the same thing, which is basically DNA assignments that I basically already answered. So was that something that I would need to speak with my teacher about regarding like?
Yeah. Are these both courses here that you've taken with Graduation Alliance?
They told me that I had to take two biology classes, and I've already took the first semester.
Okay.
And with the first semester, we was talking about,
Started out with
basically photosynthesis, DNA, and then now this new class, the first week is once again back on DNA, and I'm like, okay, why am I repeating the same?
Good question. Yeah, and it could just be I'm not sure how far into the course that you have gotten, and it could just be just a quick little like recap, because DNA, with biology, life, DNA is a huge basis of it. It could just be like a quick little like, okay, remember what we already learned. But it might also be, I'm not sure what courses you were in. If it could be maybe you were put in the different a different course than what you should be in. So if you are feeling like, wait a minute, this is the same thing that I've already done, I would reach out to, if you have a coach, if you have, talk to your teacher, and they can look and see, is this the right course for you?
Okay, thank you.
Anything else coming up on your mind?
Oh.
Good. Okay. Well, I'm glad to see you guys take advantage of these courses. It's great. On my hand, it's really nice to hear you guys speaking. I saw a couple faces in there, here and there. I know sometimes it's funny, like, oh, there goes my face just came up. All good. It's nice to see and nice to get that interaction. So definitely continue with these sessions, you guys, and your teachers will continue with these sessions, and hopefully they are helpful and meaningful to you guys.
How often do you guys do these type of classes?
Right now we've got them on the schedule. Let's see. I know that there is, like, I want to say there is at least 2 a week.
Okay.
That is going on here. Yeah. Let's see if I can. Yeah, so this was kind of gives you the schedule. So yeah, it was looking about 2 every week. We had them going at different, and they were at different times, and it was taught by different teachers. So I'll be doing science again next week, and I know we had the math teacher and English and social studies as well.
Yeah, and Amy, this is Rachel. Can you hear me?
Yes, thank you. You can
Hi.
Like, did you pop in there?
Yeah, I'm jumping in. So, hi, everyone. My name's Rachel. I've been helping coordinate these sessions. So to answer your question about how often they're happening, usually it's about 2 per week. Next week, we're actually having 3. We have an English one on Monday, another science one. I believe yours is on Thursday, Amy, right? And then our history teacher is doing hers on Friday. So you will be getting more emails and texts and dashboard announcements if you are enrolled in any of those classes, or of course the science one. Would love to have you back next week. But this is something that we've just started doing this month. So if you like it, obviously let us know. The more people that say they want it, then we have more reason to keep doing it, So really keep continuing to come and support it and have that relationship. It's really cool because, as you can see, you can actually see Amy's face right now and like get to know your teacher as a person, not just someone giving you, written feedback and like a % grade and moving on with your life. So that was kind of a long answer to a short question, but the schedule we will continue to push out to you. And we try to get it out at least a couple days before each session so you can plan accordingly. If you have work or some other commitments or what have you, we try to work with that.
Okay.
Thank you. Okay. Well, then let's go ahead and we'll wrap up this session for this week. Thank you again for everybody for joining us and taking advantage of this. Again, like Rachel said, keep your comments, your ideas, your feedback on this. If it's worthwhile for you, definitely we'd like to hear that so we can keep going on this, and keep thinking about as you're going through your assignments, if there's topics or questions, shoot it to your teachers, bring it to one of the next sessions. Great.
Okay, wait one second. I have a question. In my top left-hand corner, it says recording. And then down here, I see that there is a record button. So is this like recordable where I can go back into the computer and like re-listen to the whole thing?
So that is the idea of what we're doing. Is so I'm recording. I started recording this session, and so what I'll do after the session is that all your teachers will be doing this. Is that we'll create a file for it, and then that'll be uploaded. Rachel can speak more about where those are going to be put or kept. But yes, the idea is to keep these sessions so you can come back to them for information.
Yes. So the cool thing is we have a YouTube channel where we are archiving these, and you can subscribe to that YouTube channel anytime and follow along. So you will get notifications anytime a video is added to that channel. And like Amy said, we're doing it for all subjects. So even if you're not enrolled in US history yet, but you know you're going to have it down the line, you could still have access to those videos. So your teacher may continue to do these sessions, but at some point, 2 months from now, if you have questions and you're in that class, you can say, oh, I remember seeing a video posted about this on YouTube. I'm going to go check out that channel. So they'll all be in one place and you can watch them as many times as you'd like. There also is a timestamp in the description. So you can actually see we start talking about the water cycle at 1 minute and 37 seconds. You can skip straight there instead of sitting through and waiting until you get to the section you actually need.
Oh, okay.
Good.
Sweet.
Yep.
Good question. Thank you. Okay, you guys, let's go ahead and wrap this up. Good luck in your study. And again, we're here to help you guys. We're here to help you guys succeed. So if you've got questions, please don't feel like, oh, I don't want to reach out. Again, this is what we're here. We're here to help you guys. So don't ever hold back that.
Thank you.
Have a great day and enjoy your course.